So the final problem that we're going to do with this weak monoprotic acid titration with strong base is find the pH beyond the equivalence point when we've added too much strong base. So remember that the equivalence point volume for hydroxide was 20 milliliters. Here we've gone 5 milliliters beyond that. So we can still write our same reaction, thinking back from point 0. Okay, it's always safest to work from the beginning and do each problem independently. That one-way arrow with a strong base took us to an ICF table where we did the problem in moles or millimoles. Okay, so if you solve for the millimoles of HA, remember this is still that same initial solution that was 0.2 molar, 100 mils. But now we're adding to that 1 molar, 25 mils, or 25 millimoles. And this is the first time that the weak acid has been the limiting reagent and the strong base is left over. We have 0 millimoles of HA, but still 5 of strong base after this equivalence point. And now we've made 20 of the weak base. So we have two things in solution, right? We have a strong base and a weak base. And the concentration of the weak base is equal to 4 times the concentration of the strong base, it appears, just based on the relative amounts here, 20 and 5. However, it does not matter because this weak base has a Kb value that we calculated in the last video of 10 to the negative 10, right? Because the pKa was 4, the pKb was 10, and the Kb was the antilog of that, 10 to the negative 10. That is super weak, right? It only makes 1 hydroxide for every 10 billion base molecules present. But this strong base that remains produces 1 hydroxide in solution for every single strong base molecule. In other words, we're just going to ignore the weak base. And that is true always when you have a solution of strong base and weak base. You ignore the weak one and you say the POH is the negative log of the concentration of hydroxide that comes from the excess strong base, because that's going to dominate the solution. It's much higher than any molarity of hydroxide that's coming from this Kb expression. Or in other words, the POH will be the negative log of the millimoles of hydroxide, which was 5, over the volume, which is 125, because at this point we've added 25 together with 100 from the initial solution. So if you solve for that POH, you're going to get a pretty low value. Here I get 1.40. And then finally the pH is 14 minus that, or 12.6. Okay, so beyond the equivalence point, that problem is now just excess strong base. We do the same titration reaction here to figure out that final amount of strong base. And it overrides the weak base that is also present, even though the weak base is more concentrated. This doesn't matter. So if you were doing the opposite titration with a weak base initially and a strong acid titrate, then you would have excess strong acid and other weak acid, and you would do the same thing where you omit the weak one, right? In presence of a strong acid or a strong base, that is what's going to dominate the pH. So for more practice with titrations and problems beyond the equivalence point, you can visit either Unit 1 of my analytical course guide, or you can visit Unit 2 in the acid-base section for my general chemistry course guide, both of which are at chemguides.com.